Welcome everyone, and this is the sixth edition of this engagement.
Hello, Sam. Are you there?
I've lost sound myself.
Today we'll focus on the overview of Intersect. Ciriako will drive it. We're going to make it very interactive so we can step in at any point in time. However, I want to remind you that we're recording this section, so you also have access to the recording thereafter. We've already sent out the links for the previous sections to some of you. If you have not received that, please let us know after this section so that we can forward to you together with the feedback link. I want to encourage you to please use the link. The feedback takes less than 5 minutes. I've seen some people have already entered that. Thank you so much for that. I want to encourage other people to please do so after this session. If you don't have the link, let us know. We'll send you the link to do the evaluation and to watch all the recordings. So over to you, Ciriako.
Okay. Good afternoon, everyone. This is Ciriako Hachi. Can I confirm if all of you are able to see this, my slide, my screen?
Yeah.
Very good. Very good. Yes. All right. Right now, on this slide is our agenda for the day. I'll take you through and illustrate the capabilities and the benefits of Intersect as part of the overview, along with workflows to build Intersect models, and thereafter Intersect file structure and how easily to view the results once you have run Intersect. We will have a demo, and as my colleague Sam has mentioned, we will also be having interactive sections after the demo during the Q&A session. Starting with the overview of the Intersect capabilities, essentially here we would like to bring to your attention the importance of having a very good simulator which can address the challenges oil and gas industries are facing in the recent times and the future to come. Having said that, most of you must be aware of our simulator Eclipse. Eclipse is still the industry reference simulator. Schlumberger is still committed to developing and enhancing its performance. Along with also Intersect, Intersect came as a simulator from Schlumberger because of many aspects that reservoir engineers, general decision makers make in the recent oil and gas industry platform. As you know, technology has been changing quite a lot. We have complex reservoirs and geological models that tools like Petrel are capable of producing, along with the need for a simulator to handle thousands of wells and millions of cells. And that's where the Intersect simulator comes in from Schlumberger. Intersect is a high resolution reservoir simulator. This simulator was developed by Schlumberger to simulate without compromise, virtually addressing all the challenges that we face in the reservoir engineering world. Starting with this Intersect simulator, we have unrestricted resolution, all the way from poor scale to full field development and management modules. So it's developed to make sure that we don't have any more upscaling, and there should be no inconsistency in the geological model used by static model and the reservoir engineers. You can see in this in the figures on the left, these are quite complex geological models which can put many simulators currently to their knees. However, this Intersect simulator, this is a piece of cake for it to run. Not only does Intersect dwell on handling complex geological models, it also with it is a state-of-the-art physics which we use along with the technology. Starting with the advanced physics, a number of times simulators have been developed to handle different types of simulation. But the Intersect is one simulator for all recovery processes and also all enhanced oil recovery mechanisms that any reserve engineer would like to undertake. More so, with Intersect, you can handle advanced field management aspects of your field development and management. We have variety of strategy and controls essentially to handle all complex operation and production decisions that you may want to evaluate. And this is possible with the built-in optimizers to that help you to maximize the objectives that you intend to study. And it is also by design designed to handle network simulations or coupling. So a number of times the simulations are 2-3 fields or geological models. People want to run them together because in most cases we have gathering stations where there are 2, 3, 4 reservoirs handled together. So this simulator can handle that. And we, as mentioned before, state-of-the-art solver is being used for this Intersect to make sure we harness also the developments in the hardware and the software. So it has an intelligent domain partitioning whereby if you are running in a parallel, as we know, we now have capability of using hyperconvergence computers with very many processors or cores. With this simulator, it will scan through the model and allocate the processors according to the workload. Going specific to each of these items I've discussed, especially starting with the unrestricted resolution. There were days when someone talks of millions of cells and starts to wonder how many more months, how many more weeks I'll need to simulate as a reservoir. But now with the Intersect, if you have hundreds of millions, hundreds of or thousands of wells or millions of cells, 500 million, 20 million, it is very okay for Intersect to run in a much smaller time compared to Eclipse. Also, the structural complexity, as you see in this model on the left, you can see a high resolution model with so many cells and also the complexity of the layering. With the high resolution, you're able to capture all this complexity, and at the end of the simulation, study well where oil is used with the help of this high resolution. And where oil is left, you can easily go and tap and drill afterwards. And it is only high resolution which captures better the flow patterns in the reservoirs rather than upscaling, which may average the behavior of the fluids and also the properties, the static properties. Unstructured grids, as we know, probably some simulations are not capable of running unstructured grids that much. But with the Intersect, you can comfortably run structured grid so easily, including our own technology depot grid, which captures well all the heterogeneities and the events that happen during the deposition environment. So this is, as we said, you can see in the picture, simulator really meant for high resolution simulation. Advanced physics, I gave an overview. We have now one simulator for all recovery methods or all types of simulation, ranging from black oil composition and thermal and all forms of chemical and other enhanced oil recovery methods, including unconventionals. This is a robust simulator which can handle all forms of recovery mechanisms, hydraulic fracturing and also unconventional reservoirs, as we know. the power of Intersect is better utilized and maximized with the algorithms and optimizers which are put in advanced field management. With Petrel, Petrel later on we will see that field management can be complex in the real world, both operational and even during production. The number of strategies and operations that happen in the field, or decisions that have to be taken, and gone at the times when we start wondering what to do. How can I put this in the reservoir simulation world, and a simulator is able to take all these things I want to do. This Intersect dwells in field management, which handles all operational and production scenarios that you like to undertake, and use the results to make decisions, including the use of complex wells, ICDs, info control devices, thousands of wells, using the optimizer to decide for what strategy is well. For example, if oil water starts coming in or gas starts coming in a lot, with this simulator, you don't need to create a case for each of them or wait for run one, see where water starts coming, and then say, okay, I want to change my strategy at this point. Now I want to control the gas or water. With this simulator, you can throw all this at the simulator, set some optimization the parameters, and it will automatically choose which strategy can be used and what time. And you will be able to implement that by informing the field guys to undertake the operation. More to advance field management is the aspect of rigs. With the field management, you're able to also incorporate other operational constraints in the simulation. For example, number of rigs, the drilling time, the completion time, all that you can put in the field management, and it will be able to run for you a scenario in the same case. Above all, is also the extensibility. With this, you can use the Python scripts to enter any specific scripts that you would like to use and want the simulator use. Intersect is fully extensible to Python script, to any specific scripts that, or in-house scripts that any person, any company has and would like to use, along with the CSV driver. So essentially, you can, for example, put up uptime fractions in form of a table in Excel sheet, link the Intersect data file to this CSV file, and while simulating, the simulator will go and look at the uptime fractions of each of these wells, including the parts, and they consider that in the simulation. Superior performance. We do know that right now technology has changed really a lot, as I mentioned, both in hardware-wise and also in the codes. So with the high performance computing, this simulator Intersect has unlimited scalability in the use of the hardware. The parallel processing becomes very easy, including use of the hybrid parallel or graphic processing units, which is the latest technology, hardware technology that the simulation world is going to. From the software perspective, this software uses algebraic multi-grid linear solver, which essentially is able to make you run your case so easily, and they will understand well the workload that is needed from each of the regions of your model, and they eventually help you with the simulation time. With it, also with this simulator, we have application of the intelligence, artificial intelligence, and machine learning, which are the algorithm which I described earlier, which will help to guide the simulation behind what time step to use next. Is this time step too short? Is it too long? How can you easily optimize it? It can easily track back the history of running and seeing that I don't need to take short time steps. can take more longer time steps, and all this is done without compromising on the results. The figure down you see here is the intelligent partitioning with reference to our own simulator Intersect. I mean Eclipse. The partitioning is done without analyzing critically the workload very well in the module. But with Intersect, it looks at the workload on a step-by-step basis until it finds an optimum way of partitioning your grid, so as to balance the load very well and improve on the simulation time. Having that information with us, I'd like to show you how easily it is to build Intersect modules. There are majorly two workflows or pathways we use to create an Intersect model and run it. The most preferred one is the Petrel interface. Petrel, by design, has been developed and also enhanced the Intersect performance. Just like you'll easily run a Eclipse case in Petrel, Intersect, you use the same workflow. The only difference here is to choose a different simulator, Intersect, which is already built and to run well in Petrel with all the inputs in Petrel. The other aspect is, for example, for someone who has no Petrel and has an Eclipse case or had exported an Eclipse case and will not want to use a Petrel anymore. Such an Eclipse case can easily be converted using the migrator to Intersect, and once it has been migrated, you can now run it using the Intersect simulator, using our simulation launcher platform. Just to dive, show you the two main pathways. First is Petrel workflow. All the input, as we know, Petrel for reserve engineer is a great tool for pre and post simulation tasks. So if you have your project in Petrel or your GNG modules are already in Petrel and they have handed to you, or in the simulation of the case using Intersect, you will put all your inputs in the defined simulation case and just choose the Intersect as the simulator. Petrel will communicate in the background very well in Intersect and run your case using Intersect, and will export for you all the files that you have already input without necessarily to code manual by hand. The second one here, as I said, is for a case where you have an Eclipse case and you don't have Petrel. So you just run the migrator. It will convert it into an Intersect readable format that later on when you run, that converted case, you will be able to run easily with the Intersect. Now, with the Petrel workflow, there are two strategies you can use. The conventional strategy that we use mostly is the development strategy with Eclipse. However, with the Intersect, you can use this development strategy, but to harness well the importance of this technology, this simulator Intersect, the preferred strategy is the field management strategy. Here, the algorithms are put in place and optimized it along with other templates to help you easily model the decisions or the scenario that you will write or you like to undertake. And again, after choosing each of these, you will be able to just choose the simulator, which is Intersect, and run. We have always been working hard to make sure that our users don't have to struggle to code, to create a data file, or to do all these workflows. As we stand now in Petrel, if you have an Eclipse case and you want to convert it to an Intersect case, it's 2-3 clicks away, as you see in this picture. You just right-click on it, convert it. Once you convert it, in the conversion process, you have an option to choose either a development strategy or the advanced development strategy, which is the field management. And the conversion will take place for you. And once the conversion is complete, you'll have this case converted into Intersect, and it will be showing for you in the cases pane, along with the development strategy and the field management, which it has been using. This is also very easy. For example, if you know you just imported the case, you have just imported the case, and the inputs were not there in Petrel, or you had used Petrel just to visualize the results, it's okay. You again right click and you're able to convert it. And in this case, you'll have the third option. Since you imported it, you have the third option now to import it and create an Eclipse case in Petrel itself. That's why you have the three options. So the migration process is made easier through the Petrel. In a case where you have all your inputs and you want to create a very new case, the process is simple. After having all your inputs you like to use in a case, you'll just need to create the new case by first choosing a new simulate, which is the Intersect. As mentioned before, you have two options. Either use the field management strategy, which is equipped with so many optimizers and to deal with the complex logic that you may want to undertake in the field, or you like to use the development strategy. Once that's done, you export and run, and later be able to see the result. So you not like to go through the Petrel itself, and you have for simulation. The migration work is very easy. On the left, what you see is a simulation launcher. The first process here is to migrate. So you choose the migrator, add the data set you want to migrate. Once it has migrated, you go back to the simulation launcher and choose the Intersect simulator, add the data set and run it. That's how simple it is to migrate an Eclipse case and also run it using the simulation launcher. I've spoken a little bit about the development strategy and field management. Just to reiterate more, development strategy is conventional what forms the Eclipse schedule section. And once you have clicked on the icon on the Petrel, which is highlighted, you will have this interface in which you add the ways and the controls and all the limits that you want to during a certain study. I mentioned it also that the field management, however, is the more preferred development strategy that the person can use to fully utilize the Intersect simulator. Here you have full access to a variety of controls and robust optimization methods or optimizers which run behind. And though we are dealing with very complex operational and production decisions that or strategies that you like to undertake. With the developments in Petrel, we have made it easier for you and created ready or customized templates where you don't have to go and do a lot of thinking again or coding again. There are numerous templates which do exist. Once you choose, you have 2-3 clicks to input the data you want and again run. So in here we have in this picture we have templates like if you want to do group voidage replacement, you want to do WAG injection, gas, water, you want to re-injection, group water injection. All these templates exist. The list is more than what is here in the table. Okay, let's quickly look at the Intersect file structure and how easily you can see the results after running it. For most of you who are used to Eclipse, Eclipse has about 8 sections. Some of them are though optional, still with its keywords and the complexity. However, in Intersect, we have reduced these sections to mainly 2 categories, and out of 2 categories, we have 3 sections in total. We have one section that deals with the grid geometry and the static properties. And the other aspect is, apart from the static property and grid geometry, all other reservoir-related properties are captured in the reservoir.ixl. And the third section is the field management, which essentially deals with the field and well controls and all operational optimizations you like to do. The file structure for Intersect has been, and the language has been made it so easier for the users because gone are the times when people prefer reserve engineers, they will use a lot of coding, and the essentially sometimes they suffer a lot to try to put all these codes in different sections. With the Intersect, it's made the language is much simpler and easier. And as you see on your right, we have extensions which are labeled in such a way someone can easily understand what each of them is containing. And in case you want to easily know and edit what Petrel or Petrel as output for Intersect to use, you will just know. For example, if I wanted anything with false, I will just look here and see any word like false, and I find false. And I can easily click on this and go inside and read what is inside. This picture, as you can see, the language is very simple for anyone to read. Constant threshold pressure. So these are the threshold pressures for faults 1, 2, 3, and 4, and all the properties. It is written in a simpler English language that everyone can understand. Visualization is also easier with the Intersect. Not much difference when you are doing it with Eclipse. If you're the same methods are used to visualize, there's no any other complex method or any other software you will use to try to visualize the result. Petrel will still, as preferred interface, you will be able to see the 3D and then the line plots so easily using the methods you already know, if you haven't, which are very easy to learn to use and evaluate the results of the simulation. This powerful simulator was developed by us in partnership with Chevron and Total. As of now, more than 80% of their use powerful simulator. And you probably know Chevron and Total are also powerful operators in the oil and gas industry. As of today, so many other operators, big operators. I'm not saying we don't have powerful operators in this call. There are so many other operators out there in the oil and gas industries that do also use Intersect. Just an example here is ENI. It has in its corporate adoption used the Intersect, and they have seen a drastic simulation time reduction model in their simulation. And we even there's an SP paper for this result, and many more references you can easily get about Intersect simulation and its power and how it has helped so many operators out there, including the regulators also in quality checking, and also national oil companies in developing their own assets in their countries. Overall, you might already known that with all these characteristics and capabilities of Intersect to handle all kinds of challenges ranging from the complexity of the geological model or incorporation advanced physics, or throwing it at very many wells, thousands and thousands of wells, and the use of the latest state-of-the-art solver and the hardware. Indeed, Intersect has become the new standard in the reservoir simulation. The next session is to show you how quickly it is to interact and with Petrel and run a case with the Intersect. Samuel Just a quick mic check. I hope everyone can hear me and see my screen very well. And
Yes,
also,
we can see we can see your screen, Ciriako.
very great, very great. I don't know whether people have burning questions in the chat box, or we can go to the demonstration and then later go in Q&A section once.
We have some questions. Go ahead. We can handle everything together after the demo.
Okay, I'll switch to the Petrel screen. Can all of you see the screens well? Petrel project?
Yeah, we can see actually.
Very good. What I have here is an Eclipse case which has been created in Petrel using all the inputs from Petrel. And what we would like to do is to try to convert this case to an Eclipse case, run them and see the results. And they demonstrate that the results are the same, whether you're using Eclipse or Intersect, and even see other advantages like improved runtime. All right, let's quickly look at this case. As I said before, the inputs for this case, they came from Petrel. You can see the permeabilities and porosities are coming from here. The rock physics and the fluid module also came from Petrel. And currently we are using a development strategy. Yeah. And this is a history case. Okay. Now, as I mentioned before, if you have decided that you now want to use Intersect, it's so easy. All what you need to do is to come to this case, right click and say, I want to convert this case. So since this is already a Eclipse case in Petrel, we don't need to convert it to a Eclipse case in Petrel. It gives the option to now convert it to Intersect, either using the development strategy or field management. That's how it is, and you just click convert. So right now it's running, the Petrel is using algorithms, the simulator algorithm behind to create for your Intersect case. One will be using the development strategy, and the other will be using the field management. Once the conversion is done, it's always good to know how successful the conversion is. Starting with the case it has created where it's going to use the development strategy. We see that we don't have any errors. This is a good sign that your conversion has been well. And sometimes, since it's a migration process, it will let you know some of the keywords which it could not easily convert. And as of now, these keywords are not important in determining the results, the fate of the simulation and the results. The same thing with the case which has a field management. You have no problems, no errors. These two cases are here, one ending with DS, another one with field management. And along with, as you know, it will also output for you a field management and also a development strategy that has been used. Okay, now that we have created the case, how it is easier again, as we said in Petrel, we make it easy for everyone to run the simulation. The running is very easy. Just right click, export and run. And this one will be using a development strategy. And if you wanted to add any more results that are not there, you can easily add them. Use the same workflow you will have used with Eclipse. So we will go ahead and run these two cases by just right clicking and saying export and run. Once they have run, we will compare the results and they see that the results are not different, and they will have demonstrated how easy it is to convert any Eclipse case to Intersect case. Simulations are here. They are running. Just to demonstrate also later on improvement in time, we can easily look at this data file and see how many processors are used. So for the same processors, We have here 8 processors that we have used. And we can also check that it's the same number of processors we have used for these cases. And we will later compare the improvement time by just choosing a different simulator. Here again, we are using 8 processors. Okay. So the simulation is done actually. As of this point, we can now compare the results of these 2 cases we have run. So you can't see any difference between them. Yeah. If you like, we can dive deeper and check if there are any differences. You don't see any difference. So it's one-on-one. Same input, same simulator, different simulators, but same results. Okay. Suppose you don't have an Eclipse case, but you have all your inputs there, and you like to form a intersect case, a history case here, because the cases were running a history case. You will come to field management and form your own field management. For example, since the other cases are history, I can easily set up a history case using this field management. The observed data is in there, okay? And the next thing is to activate the history mode by choosing the historical control mode. The historical control mode we use for the Eclipse case is the liquid production rate. We can check that so easily using the development strategy. Just to be sure. So let's look at the control, liquid production rate. Yeah. Once it's done, just say okay. And then we go to define simulation case and create our own, create a case which uses this field management strategy we have just formed. The inputs are there still, same fluid, same everything. And the simulator, we make sure is Intersect. Yeah. Let's give it a name. In this case, I'm giving demo FM. When I go to strategy, I say I don't want to use this time development strategy. I want to use field management strategy. And I will add this field management strategy that I just created, which was called demo. I just say apply or okay. Yeah. And then the case will be created in the cases pane. Again, export and run this case and compare the results. Up to this point, I've demonstrated how easy it is to convert an Eclipse case to Intersect case using either development strategy and field management. I've also demonstrated how easy it is set up an Intersect case and run them. Once this current run list, I will also plot the results here. Since the inputs are the same, there should be no differences in the results. Okay. For example, if I use these two, just the results are one-on-one. So other demonstrations, for example, if I wanted to see the partitioning using the Eclipse case for the 8 and also partitioning using the Intersect case. So let's see how the partitioning was done in the Eclipse case. Okay, so this is how it was done. Linear, as you see, doesn't matter what the challenges exist in this region. It just decides to choose and split them 8 times. How about in the Intersect case? If we look at the Intersect case, you see we're just looking for the partitioning, parallel partition domain. This is how Intersect intelligently partitions the module depending on the workload and able to improve on the simulation time. Quickly on the file structure. This is Eclipse, as usual, with very many keywords being used, yeah, everywhere. We all know if you want to create, for example, put a new well, there are so many keywords which has to go in. If you compare this and the inside here, not easy to easily understand what's happening, but as compared to Intersect, the language which is easily understood by a lay person, a lay reserve engineer, even if he hasn't advanced his or her skills. For example, if I go direct to what I showed before, yeah, in the presentation, the faults, I can easily know, okay, what are the threshold pressures for these faults? What are the fault properties, transmissibility multipliers for each of the faults? I can easily read them. Same thing with the fluids, the rocks, I can easily read. They are written in a language which a person can easily understand. That will be all from my side. Over to you, Sam. Let's go to the question and answer session.
Well, thank you so much, Ciriako, for the presentation and the demo. The bottom line of the overview that we've shown today is just to show the benefits of using Intercept and simple workflow on how to create Intercept, either directly from Petra or we migrate existing Eclipse case to Intersect. Now that we've seen that, we will move on to the question and answer section. And I just want to also remind you that we will start other sections on Intersect from next week. So don't miss that. Today we've given the overview. We'll go a little bit more about different aspects that you may want to know about. So the first question that I can see here, that's from Kim, asking about runtimes. Is the main driver for reduced runtimes compared to Eclipse is the use of hybrid GPU, CPU solving, or is there something else? Okay, Ciriako, I can take that if you want.
All right. Okay, no problem.
So, okay, you're right. We have the hybrid GPU, but more importantly, if you look at we can separate this into two. Some technologies that are helping, like the linear solver. We have a more advanced linear solver. Also, in terms of the parallel scalability that we've got, Ciriako just shown, we have a more, intelligent partitioning in Intersect, which also helps a lot. We've also introduced the multi-scale. We also have the artificial intelligence time step sizing. So there are a lot of technologies put together to really make this happen in terms of reducing runtimes. Of course, like you mentioned, the hybrid is also there to ensure that we effectively, the hybrid manage the communication. Okay, so that is also helping with the memory usage. So there are a lot of technology that makes it happen. Kim, is that okay for you?
Yeah, that's okay, yeah. Thanks.
Yeah, thank you so much for that. Okay, let's move on to the next question. I think it's also coming from Kim. You also mentioned unlimited. Do you mean in terms of, yes, I guess I mentioned that already. So let's see if there is any other question before we start taking questions directly from the room.
Sorry, can I just ask a question here? Because the scalability, I think that's an important point, and you haven't touched upon that.
Okay, sure.
When you say unlimited scalability, do you mean in terms of parallel cores?
Hi, Kim, Sam. Apologies. This is Henio speaking. And just to elaborate a little bit on this question, Kim, what we want to explain is that you're able to use as many processors to be able to simulate your case, and there is no a physical limit on the number of cores you can use as long as these processors are available, and your model will allow you to partition the grid successfully. Of course, that there will be a limit or a number of cores where you have scalability, which mainly means the reduction of simulation time. So there will be an optimum number of processors linked to your model, which will allow you to further reduce your simulation runtime. For some models, maybe 128. Some models you may able to reduce the time with 250 processors. And some models, because they're small, you have an optimal number of processors, which is, for example, 32. But Intersect will allow you to automatically and intelligently partition your grid, look into the challenge the grid has to accommodate the number of processors available to put to run.
Thanks so much for that, Enio. Kim, just to also add a little bit on that. So when we talk about the parallel partitioning that we're talking about in Intersect, which we said the intelligent partitioning, if you look at what we do in Eclipse, sometimes if you really go high on the number of processor, then you might have some maybe inactive cell being allocated to some processor, which may stop the simulation run. And you may have to manually, using the PS splits and so on and so keyword, to make sure that you reset things. But this is not the case with Intersect. It figures out based on the transmissibility, the communication that may exist in your grid, to create the number of partitions for your parallel runs. And that is when we say you can go on as much as you have. But this is dependent on the size of the module, because at the end of the day, like Enio said, to really have efficient scalability, there will be like minimum, by the rule of thumb, maybe 50,000 cells per processor to really gain that efficiency that you're looking for. I hope that helps.
That is super interesting. Thank you very much. That clearly answers the question. You said about 50,000 cells per processor. That's your rule of thumb that you're suggesting?
Yeah, as a rule of thumb, if you're getting there, you probably don't get so much scalability value again. If you go above, if you have less than that.
Okay, excellent. Thank you very much for that.
You're welcome. Okay, so moving on to the next question. I'm not sure if I'm the only one. Okay, sorry about that, Revelation. I see that you, maybe because of the lag in the connectivity, you were having difficulty to follow the demo. We will send the recording and make sure that the lag is removed from the video so that you can watch it again. Going to Ikwan. How is the stream matching made easier with Intersect? Okay, very good. So when we talk about the concept of history matching is independent of the simulator, right? If you look at the history matching, maybe if we're talking about the performance benefit that we can get from intercepts, yes, we can, that might make some difference. But in terms of the flow, the concept, the way we match it, the way we define the problem and solve it, I think is basically the same. History matching itself is independent of the simulator that you're using, the concept that you are applying. Or maybe I'm not getting something from your question. Please, you can just speak so that we clarify and move
on. Hi, Sam.
Yeah, that's okay for me. Thank you.
Okay, thank you so much. Elio, you
And
want
I
to
would
say
like,
something? Yeah.
yes, I would like to actually go a little bit in detail on what you have said. Um, by being able to run your models in a faster way, so you actually can analyze more and do more detailed elaboration analysis through your history match and using Intersect. So you can, for example, use uncertainty and optimization workflows and manage and handle your uncertainties in order to see which cases match your model. And by having Intersect, which allow you to simulate further and faster, so this will actually give you a gain on the runtime and on the performance, like someone was mentioned. So this is an added value on the time frame for the history match analysis.
Yeah, thank you so much for that, Daniel. Another question from, do I need a separate license from Petre RE license? You need to run Intersect. So Intersect is it's a simulator that requires a separate license, right? Just like Eclipse requires a license. And Petre RE is also the pre and post processor. It has its own Intersect. There are different options that we have. We have a bundle license that gives you the opportunity to run whatever that you want to run because you have access to both Eclipse and Petre RE and the Intersect. So if you have such license, then that will not be a problem. But if you have just a separate Eclipse and Petre RE, then you will require Intersect license to run Intersect. I hope that helps. So Yesa say, how much is Intersect now? So the discussion on the price, we might not be able to take it on this platform, but we can contact you after this section and take that up. So I will take notes and we can have a discussion with you or get our account manager to talk to you thereafter. Okay, so most of the commercial aspect is handled by another team, so we'll put them across to you. Okay, so Kim also asked another question. What is the language used for coding an Intercept deck? Can we write it like Eclipse deck, or do you have to use a preprocessor like Petre? Oh, very good. As you know, Eclipse is driven by Fortran, but now we use a modern technology, and that is why you don't need the run spec again for memory allocation because it can do dynamic memory allocation. So using C sharp as the to drive Intercept. That is number one. And in terms of whether we can write it like a deck file, this is not a recommended way to develop Intercept file, if I must say, AFI file. PR is the recommended interface for Intersect. So we can edit. We have access to editor that can help you to edit whatever you've created in Petre if you have to do that. But to really create the case, like Ciriako said, if you have existing Eclipse, you can migrate it, or you can just build a new case in Petre, which is the recommended workflow. And you have to manually do them. But as of today, you are able to migrate almost all the keywords, regardless whether you are in E300 or whether you are working in E100 Eclipse. So that shouldn't be an issue. And if you find any, maybe in your own specific case, if you see any migration issue, please do not hesitate to escalate to us. Does IS have the same module license options sold separately as we have for Eclipse? I need to buy a dedicated license for, let's say, well ICD. Okay, very good. In general, we're trying to bundle things together. And many of you last week, you were in the session when we talk about DeFi solution, where you don't even have to think about license again or infrastructure. You just use the technology, and it is based on your subscription, the time you are spending, and not any limitation to any license or to anything again. And that is the future. This is where we're moving to. But as of today, we've reduced on that to really simplify the complication for the client. So if you need to buy, just talk to your account manager. You can also talk to Enio or Sophian, or you can talk to myself or anybody in the team. We can put you across to our account manager to make sure that we give you fit for purpose solution. Okay, another question from Kim. Can I use FM strategy with Eclipse? Okay, the answer is no. And the reason being that FM is a very, very robust strategy that is specifically designed for Intersect to support all the features that we've been talking about in Intersect. Eclipse would not be able to use the same formulation. On the other hand, you can use either development strategy or field management strategy with Intersect, but you can only use development strategy with Eclipse. Great. Thanks a lot for the questions, Kim. If you have any other question, feel free to talk to any of us in the team. Any other question? So at this point, I will just hand over to Sophian to round up the section. Thanks so much for that good feedback. We really appreciate that. Sophian?
Hi, Samuel. I think we may have lost Sophian, so I will do the main closer remarks. Okay, so sure. One more time, I would like to thank all of you for joining this session. This is a way to reach all of you within this pandemic COVID time and show you all the advances we have within our main technologies. Please, if you have additional questions, do not hesitate to reach us, and we'll be happy to address them. There is the next sessions next week, so we'll have a more detailed approach and view into Intersect and going to the field management complex templates, and where you can understand more in detail some of the questions why we can always reverse back to Eclipse and the value that Intersect brings. So I would like to invite all of you to join, and if any of team member or if any member of your team did not receive this invite, please forward to them so that they can also participate. And the list of the following sessions are here present. We urge you to answer the survey, please, like someone said, and we look forward to see you next week. Thank you very much to all.
Thank you all.
Thank you all. Thank you all.
Thank
Thank
you.
you. Thank you.
Thank you. Bye.
Thank you. Bye.
Thank you.
Thank you, everyone. Bye-bye.
Thank you. Thank you.
Thank you, guys.